Let's take a look at decay of the vector W boson. First, in terms of the ordered pairs of the combinatoric schema. And so here we have a scalar boson minus represented by the ordered pair S equals 3/2 and T equals -3. Which maps to the T and V assemblies. We can see on the top we have a +1, 2, 3 V, which gives us a 3 of the S 3/2, and on the bottom we have a -1, 2, 3, which gives us the -3 of the T component. We can see that graphically here. Now, associated with that scalar boson minus is a vector boson, which is composed of V and anti-V pair. That V and anti-V pair provide the -1 spin to the vector W boson. So together, that vector boson 0 and the scalar boson minus compose the vector W boson. And we'll see that we have here a particle-antiparticle pair being a generic anti-electron and electron, or anti-muon and muon pair that we will see will interact here with the scalar boson minus. So here is this pair. This pair then interacts with the scalar boson minus in this way. The anti-V prime replaces this T rishon here. They both have the same color, yellow. So this yellow V, anti-V prime, replaces this T rishon. And this anti-T prime rishon then combines with this T rishon, it being purple, or the anti-color of the yellow, and together that the boson 0 formed of those transits over to this anti-T rishon, and this yellow T rishon then annihilates with this purple T rishon, leaving this anti-T prime rishon in its place. And we'll see the new particles that are formed as a result of those interactions. And so, after the interaction between the muon, anti-muon, and muon pair, you will have two new particles. And these two new particles will be anti-neutrino and an electron. This anti-neutrino will combine with the vector boson minus to give it a spin of -1/2, and the electron will have a spin also of -1/2. So the two together will have a combined spin of -1, just as the vector W boson that decayed had before their production. So in that way we can see how the vector W boson, through this interaction with a generic anti-electron and generic electron, are anti-muon and muon interacting with the components of the scalar boson minus, will compose the anti-neutrino and anti-electron. In the next video, we will investigate the quanta of these compositions to see if they will correspond exactly with the quanta of the anti-neutrino and electron in the standard model. But let's briefly take a look at these two particles in terms of the combinatoric schema, the ordered pairs representing the combinatoric schema. And so here we have the electron. And so the electron, again, as we see, we have the initial electron, or muon, anti-generic electron, or muon here, and we have a T-richon here, which will annihilate with one of the T-richons in the muon, just as we saw previously in the interaction, and will leave the anti-T prime in its place, just as took place here. And also in this case, we have an anti-muon or anti-generic electron, and similarly we have here an anti-T-richon which will interact with this T-richon, and those will annihilate and leave in its place this anti-V prime richon. And the two negative T's then annihilate the T-richons here. They don't annihilate, but they cancel out the charge, and so you have a zero charge, as you would need in the formation of the anti-muon. And then, of course, as shown graphically, this antiparticle and antiparticle pair of V richons provide a vector boson to give a -1/2 spin to the anti-neutrino. And in the next video, as I previously mentioned, we will take a look at the corresponding quanta to see if it satisfies those required by the standard model.